Okay, welcome back to another session of data analytics class. In the last class, we discussed the regression analysis. We actually derived the regression equation using the method of least square. Those who have not watched that video are advised to first watch that video because it is kind of prerequisite. So in that video, we derived the regression equation on y on x. This equation can be written as y minus y bar is equal to b yx x minus x bar. We have derived the value of byx, or simply b, as n sigma xy minus sigma x sigma y upon n sigma x square minus sigma x whole square. Here n is the number of observation number of samples. So today we'll see some solved example on regression equation, and we'll also try to code this using Python, right? If we want to find the equation of regression, line of regression of x on y, this can be written exactly in same way, like this. Y minus y bar. Here actually simply the x will be replaced by y. Here b, our bxy will be n xy minus sigma x sigma y upon n sigma y square minus sigma y whole square, right? So we have simply changed the x to y and y to x. This is the equation, regression equation of y on of x on y, right? So now let us see one solved example. And then we will code it using Python. Suppose the x and y values for some given data are 1, 2, 3, 4, 5, 6, 7, 8 and 9. Here this x is the independent variable and y is the dependent variable. Suppose the value of y corresponding to 1 is 9, then y value corresponding to 2 is 8, 10, 12, 11, 13, 14, 16 and 15. So what is our objective? Our objective is to find the line of equation of line using the method of least square, using the method of least square. So here we only need to calculate. Let us see in this uh, the equation of y on x is y minus y bar is equal to byx into x minus x bar, right? So we only need the value of this byx. X bar and y bar we can calculate using these columns. And what else we need? We need xy, and we also need x square. So this is all we need. Let us try to compute these values. Here if you sum the x, so sigma x is will be equal to 45, sigma y is 108, here xy will be 9, 16, 30, 48, 55, 78, 98, 128, 135. If you add all these numbers, the sigma xy will be 597. Similarly, our x square, 1 square 1, 4, 9, 16, 25, 36, 49, 64 and 81. If you add all these numbers, it will be 285, right? Now let's put all these values in our equation. Yx is equal number of observation is 9 into sigma xy minus sigma x sigma y upon n sigma x square minus sigma x whole square. This will be equal to 9 into sigma xy is 597 minus sigma x is 45 into sigma y 108 then 9 into x square sum 285 minus 45 square so if you solve this will come out to be 0.95, right? If we put this value in this equation, the y minus y bar, which will be our 45 by 9. Let's code the linear regression using Python. This is our Jupyter notebook. Let's open a new Python file. So for linear regression, we first need to import some library. So let's import pandas as pd to store the data, and from linear model from sklearn import linear model. Run those cells. See, our linear regression model is in the linear model package. The sklearn is a machine learning library that contains many useful methods. Now let's create our data frame, which we have just used to solve the regression line. For this, let's create a list of list 1, 9. This 1, 9 is our first xy pair. This is our x1, y1, then x2, y2, x3, y3, x4, y4, x5, y5, x6, y6. This is comma actually. X7, y7, x8, y8, and finally x9, y9. Let's convert this list into data frame using pd.data frame method, and data we can give column some name. Columns is equal to, the first column name is x and the second column name is y. Let's run it. Okay, perfect. Yes, let's check our data frame. This is our data frame. So now what we need to do, we will will drop the target variable in the data frame and store it in the dfx. df.drop. The target variable is y. Axis is equal to 1. Perfect. And the target value, let us store target value in dfy. df.y. Okay. So our dfx and dfy we have computed. Now let's create the linear regression model. Reg is equal to linear underscore model dot linear regression. And fit the model. Reg dot fit dfx comma dfy. So our model is ready now. Now we can do the predictions. So let's see if we try to predict what will be the value of y if we pass x as 10. It will be 16.75. Now let's see the coefficient of our regression line. reg.coef coefficient, it is 0.95. it is same as we computed manually. And let's see the coefficient, the intercept. What was our intercept? Our intercept was 7.25 and coefficient was 0.95. 7.25, nearly 7.25. So this is how we can solve the regression problem using manual method, using the equation of line, least square method, and we can also plot it very easily using sklearn library of Python. Right. Now let's try to create a multivariable regression model. The model we just create was linear model because there was only one dependent variable. Now let's create a multivariable linear regression model and try to solve using Python. Let's take any random data. Suppose we want to predict the price of a house based on number of based on its area and number of rooms in the house, the age of house, and these three factors contributes towards the final calculation of the price. These three factors decides the final price of the house. Let's take any random value. Suppose for 800 square feet of area which contains which contains 2 rooms and which is 5-year-old, the price is say 20 lakh. All this price in lakh. For 1000 square feet of area containing say 3 rooms, 4 year of age, say the price is 23 lakh. Let us take some random values and try to predict the price of a house having x1 area, x2 number of rooms, and x3 age using linear regression. Right? The equation will be like y is equal to b0 plus b1x x1 plus b2 x2 plus b3 x3. Let's use our Python notebook to write this. Let's make a copy of this. And change the we need to import the same library here in this example also. So the first parameter was area, 800 square meter square feet, sorry, and 2 rooms, 5-year age, 20 lakhs. Similarly, let's take any random values. 1000 square feet of area having 3 rooms, 5, it is also 5-year-old, 24 lakh. Suppose 1200 square feet of area, 4 rooms, 10-year-old, 30 lakhs. 1300 square feet of area having 5 rooms, 5-year-old is 4 35 left. Suppose the name of our columns are area, rooms, age, let's run it. This is our data set. So like in we have done in previous example, we need to drop this price cell. This is our x. This will be our independent variables for our model, and the dependent variable is price. Now let's create the model. Now let's calculate the price of a house which is having 1500 square feet of area, 6 rooms, 4-year-old. So as per our model, it will cost us 38.6 lakh rupees. The regression coefficient is minus 0.03. This coefficient is for x1, this is for y1 and x1, x2 and x3, and the intercept is 22. So I think this session is useful for you. Thank you. See you in the next video.